Everyone. I'm new to the whole Crossplane community. Like many of you all, even got this nice fancy Crossplane T-shirt. So I think this project will be around for a while. The T-shirt is the threshold in terms of your longevity. So I'm going to do a little bit of a live demo. We're going to do a little bit of Q&A a little bit later, but I want to just touch on a couple of things that I've been personally think about when I looked at Crossplane for the first time. And I'm pretty sure some of you have been thinking some of the same things. So I'm going to just share my screen really quickly here. And I'm just going to jump right into it. So like many of you, the first thing I did was just go to the crossplane.io website. And then from here, you can kind of see it's like manage any infrastructure your application needs directly from Kubernetes. And as much as I love Kubernetes, for me, it's not the end all be all. But there's a reason why people are leveraging this Kubernetes platform to do things like configuration management. And for a lot of times, I like to compare a lot of these tools to the configuration management space. This concept of you can declare some infrastructure and have some other tool automatically reconcile the state for you. And I think this is what most people see as the holy grail in terms of automation for when it comes to infrastructure. But looking at this page alone, you can't get all of the details that you're actually looking for. So before I adopt the tool or even take the time to use it, I want to understand what's the thing that's going to do for me in particular. So the first thing that came to mind for me is, oh, this is like Terraform, but instead of using HCL, which is the Terraform configuration language, it's using YAML from Kubernetes. This is the first thing that was in my mind. So I did the mistake of comparing Crossplane to Terraform. And at the surface, they're very similar. I can see how people can get confused. For example, one thing that's nice about Crossplane is it has a bunch of control loops, if you will, built in, meaning there's resources for cloud providers. For example, let's say I'm on Google Cloud and let's say I wanted a Cloud SQL instance, right? Of course, I could use the command line tool. I could use the UI. I can click through here. I can choose a bunch of options for doing this, right? So for some people, they will call this click ops, right? You're using your mouse to click on everything. Hopefully you remember what you clicked on. And some people will even create screenshots and circle things in red and say, hey, this is how you create a particular instance. And we all know there is a different way of doing that. And the other way of doing this is like using a command line tool. So you can either wrap it into a script, or maybe you're more used to tools like Puppet, Chef, or Ansible, where those can actually let you write in different languages instead of Bash. Ruby or Python might be your jam. The other thing people do is tend to put these kind of things in something like a CI/CD tool. So maybe you're checking in your configs and you pull them down. But we get the high level thing here is I want to manage these cloud resources. So the thing that Crossplane does that makes it very similar to the Terraform world is it gives you a Kubernetes way. Remember what the site is talking about, using Kubernetes to manage any infrastructure. So what I'm going to do is focus on things like databases and not necessarily the applications you deploy in containers. All right, so to do that, I'm going to switch to my terminal. So here's what Crossplane brings to the table. It has plenty of resources built in. The one I'm using for this particular demo is just going to be a Cloud SQL resource. And if you view the documentation, there's other resources for like Azure, AWS, you name it. And plus, it's extensible. It's Kubernetes, so you can probably make your own control loops and make your own resource definitions. Now, the thing here is when I installed Crossplane, I got a bunch of CRDs. So for people that don't know what CRDs are, these are custom resource definitions. Out of the box, Kubernetes knows nothing about database.gcp.crossplane.io. But the nice thing you can see here, I'm just going to pop over to my Kubernetes cluster really quickly, is I have a Kubernetes cluster that I have built up. But you can just look at Kubernetes as a host for running my Crossplane install, right? So Crossplane is just leveraging the Kubernetes CRD model and using it for storing things. Now, if I go over here to my object browser, you'll see I'm using GKE here. But in my object browser, I can actually see a bunch of CRDs that got installed. And in those CRDs, I'm just going to show a little bit more of them. You can see that I have a bunch of Crossplane particular things. For example, I can have a bucket, I can have databases, I can have all kind of things here, right? There's a bunch of resources that come from Crossplane. even things like a provider, if you will, so I can store credentials for GCP. And again, the resources we'll be working with are our database instances, right? So I can do a Cloud SQL instance, or I can define a Cloud SQL instance class. So these are some of the resources that you get out of the box. But the key point here is that Crossplane is almost this meta control plane, if you will, for allowing us to describe all the attributes it takes to manage cloud resources. So instead of me clicking around in my browser or using the Google command line tool, I can now start to define things using, for some of you out there, you love YAML. Guess what? You get to write more YAML. So here's a bunch of YAML, and you'll notice here we get a new kind, Cloud SQL instance. I can give it a name, and then for the particular provider that's being managed by Crossplane, so this is Crossplane's control loop running in the background, I can give it some parameters like what region I want, the version of Postgres, maybe how much storage I want, and when it's done, I wanted to write the database credentials to this secret. So this is where Crossplane starts to do a little bit deeper integration with Kubernetes itself. You can almost look at this as a shortcut of saying, go create that database, wait for it to be finished. And once it's finished, I want you to grab the credentials and store them in this particular secret. So a lot of you looking at this and say, look, I could do all of this with Terraform. And the truth is you can, right? So this is more of a one-to-one resource mapping. So let's run it. So we say kubectl apply -f, and we'll say our Cloud SQL instance called production. And just like you could imagine, we're submitting this to the Kubernetes API server, and it will be picked up by the control plane control loops, right? So Crossplane is there watching for these resources. Actually, it's all of the providers that are actually watching for this. And if we go back here to our Cloud SQL instance, and I hit refresh, we should see the database server come up, right? So this is, again, this is that one-to-one mapping. But to me, this isn't the most interesting thing about Crossplane. Yes, I get to write Google Cloud resources in YAML instead of maybe HCL. Maybe I'm already using Kubernetes for other things. We'll wait for this thing to pop up here. But the real truth is, the whole point of this is that I want to be able to keep a single workflow. So let's do a refresh here. Let's make sure that this is actually running. So we'll say kubectl get managed. All right. So it looks like something is breaking here. Oh, I bet you it's going to be the name. There's a Google Cloudism here. So let's try something here. So we'll say production. Let's give it a different name. Let's say dev database. All right. And then let's do an apply here. All right. This is that live demo. It's not live unless it breaks. Okay. All right. So we'll create this database resource. Let's list them out. All right. So at this point, ideally, this should start creating inside of GCP. And if it doesn't, I feel really sad because it's supposed to be awesome and work amazingly. Oh, nothing there. All right, this is feedback for the Crossplane team. It doesn't work for me, but I'm pretty sure it might be something in my setup. But we can move on. Maybe we'll give it a little time to reconcile in the background to see if it actually comes up. Let's see if it will sync up on its own in a moment here. The next step to this is, once you have this one-to-one mapping, the next thing you think about is, what can I actually do that's interesting? If you look through the documentation of Crossplane, the thing that I think is the most interesting is to be able to create your own resources. So if you go over here to the docs, you'll see the ability to provision and publish infrastructure. If you click into that, the main thing that you'll see is that you have this ability to define your own infrastructure. And a nice thing about this is you can actually start to layer in either existing CRDs that Crossplane ship with, or actually write your own. So the key to this, to understand this, is that I'm just going to show you a bunch of more YAML config here. The big challenge here is writing a lot of these definitions, publications, and compositions. You can read more online about what these actually mean, but the whole goal is you want to take a lot of the parameters that you would typically expose in a one-to-one mapping, and you want to reduce it to a set of requirements, right? So if I look at this test requirement here, the only thing I want to expose to my developers is maybe they can figure out what provider they want, so maybe Amazon, Azure, or GCP, and maybe they can tell me how much storage. Everything else is going to be hidden behind what I would consider policy. This is how we create SQL databases at our company. And the only thing we will allow you to change is this particular storage parameter. And then once it's done, again, write database credentials here. Now, the nice thing about this is you can go start to define your own infrastructure, whether it's creating Kubernetes clusters, spanner databases, or other resources on other cloud providers. The whole thing to keep in mind here, the fundamental concept is we're starting to move from a world where we're scripting things out. And the big thing missing from, I think, when I was working on prem as a system administrator is we never had the thing that the cloud had. The clouds are really easy to use, or they have a much more self service API. And the fact that cloud providers have a control plane. This is the biggest gap that I see when enterprises or even smaller companies attempt to provide self service automation. Sure, you can do a lot with CI CD, where you put a bunch of pipelines in place. But here's the thing about most pipelines, they're pretty brittle. Most of them don't reconcile failed resources. If a resource were to fail, your pipeline is just going to tell you, hey, that didn't work. And it won't go back and clean those things up. So, what we want instead is to say, if I'm on a platform team, I want to be able to articulate my own resource types and then provide an API to the platform team. This is a subtle difference between the way most people think about configuration management and automation tools. Typically, people are saying, hey, you can have a tool and here's a service account to let you do what you want to do. We're going to flip that around and say, we don't know what people want to do, and we're not going to necessarily force them down a particular path in terms of tooling. For example, we couldn't mandate everyone use Terraform, but what if people want to use Ansible or some other tool? The nice thing about this particular world is once I have this resource requirement in place, we'll hit apply here, and we'll see if we can just have this instance get created. So this is a meta instance that I created earlier. And the whole goal here is that once this is in play, let's see if this one creates. Once these are in play, what you can see this one actually coming up here. So once these are in play, we'll click over here to our Cloud SQL console, hit refresh. I can either use the Kubernetes command line tool to do all my work, but the truth is you don't necessarily need to use Kubernetes. I know it's right there in the name. I know it's right there in the title. And a lot of people will gravitate to that world of thinking. Let's just go give everyone kubectl. The truth is that's not the way to think about this. So what you have to think about this is more of your platform team, for all intents and purposes, is the cloud provider in this case. And your goal should not necessarily to leak your infrastructure details, but to provide a self-service control plane just like the cloud providers do. So you can see that this is spinning up now. So the thing that I want to make sure that you understand, even though I use kubectl apply here, we could have definitely used something like curl. So let's try this with using something like curl. We can say, hey, curl, give me all the Cloud SQL instances in this particular infrastructure. We can do a list like that. And you can see what I'm doing here is I'm returning back the database objects, right? So that would be very equivalent to running like this git command. So, as far as we know with Kubernetes, you can actually have a RESTful interface where people can create objects using a command line tool or something like curl. But what happens if people want to just use Terraform? So this is the part where I want to wrap up. This conversation is less about Crossplane versus Terraform. This is more about using Crossplane to build your own kind of API server, your own control plane that highlights and exposes only the resources and the properties that you want people in your organization using. This is a little bit different than saying, hey, here's access to GCP, knock yourself out until we get the bill. This is more about saying we have a bunch of policies and things that we want to do, and we want to create our own set of resources that provide that same convenience. So guess what you can do? Well, the Terraform team has been working really hard lately. And I think yesterday they announced that they have a generic Terraform provider that can deploy and manage any Kubernetes resource type, right? So if you've used Terraform with Kubernetes in the past, maybe you use it for objects like pods or secrets or even config maps. But what happens if you're using something like Crossplane as your underlying platform to build your own control plane. In this case, you're exposing not only a REST API, but a Kubernetes like API. That doesn't mean that you have to go around giving all of your teammates Kubernetes. Ideally, they can keep using Terraform. So the way this works is, and here's the part that gets a little bit interesting to me, and this is kind of the world that is enabled when you start thinking less about infrastructure as code and you start thinking about infrastructure as data. So instead of Terraform having to do the hard work of calling Google Cloud SQL APIs directly, instead, it can call our control plane. Yes, our control plane is running on Kubernetes. Yes, Crossplane is in the background, but no one needs to know that. So if you look at this here, this is a YAML file. They have a nice helpful tool the HashiCorp team does. So what we can actually do, we can actually run a tool to convert our YAML files into HCL. So you can see they have this command called tfks. And what it will do is take that requirements file and just translate it for us. Okay, so let's do this really quickly. We'll just run this conversion command. And what you'll see, it does the things that you expect it to do. It generates the proper HCL. In this case, I'm going to be using their new experimental alpha provider for Kubernetes. The nice thing about this is it's going to roll at some point into the stable one that they already have, but they gave us something that we can test quickly via this alpha. And then what you'll see here is a generic manifest type. Notice that it actually understands our custom resource definition. So this is the PostSQL instance that I created. It's a requirement. So it's hidden behind all the other providers so I can expose my own. And this just is a clean mapping between Kubernetes YAML specifications or things you define in a YAML file to what HCL needs. So for all the Terraform users out there, you can actually continue to use Terraform. It's just that your modules are a little bit simpler, right? So let's say we want to create that database here. So what we'll do is I'll show you the TF that I'm using. And this one's going to be called test. And let's see if we have one already. So let's go look at our databases, and we have this default one called test here. So let's go ahead and delete that one from Kubernetes. I want to show you the other part about Crossplane. So we'll say kubectl delete -f. And what we'll do is we'll take our requirements and we'll remove it. And ideally, if everything is working, we should be able to see that the database gets cleaned up. All right, so it's gone. So that's that Kubernetes style that we're all used to. Create a resource, it gets reconciled. Remove the resource definition, it gets deleted. You can also control that in your spec if you don't want the tool automatically deleting your database. That might be bad in production. So now let's let Terraform do it instead. So no kubectl, no curl, preserve our Terraform workflow. So I can say something like Terraform plan is the thing most people like to do, but let's be bold and just call and apply directly. So what Terraform apply will do is, since it's super smart, it actually knows how to evaluate the differences between what you specify in your Kubernetes manifest defined in HCL to what's available on the server. So this is basically saying, hey, look, these fields are going to change. And if you notice here, since this is a new resource, since I deleted the other one, it's going to be a clean install of this particular resource definition. But let's say I only want to change one of the parameters, then you'll see that delta. So Terraform is asking us, do we approve? We'll say yes. So at this point, Terraform is just interacting against our control plane, just like if we were our own cloud provider. And if this is actually working, what we should see on the back end is we should see this new database start to get created. So we'll hit refresh here in our browser. And if everything is working, we should see that this database is now being spun up. The nice thing about this particular workflow is, let's say you don't want to use Terraform anymore. You still have all of the state inside of Kubernetes that another tool could pick up and move and pick up where you left off. So we say kubectl get managed. This is one of the resources that gives me all of the things inside of this group. You'll see that the state is pending. So the nice thing about this is, since we're treating infrastructure as data, that means the tools are interchangeable. So with that, I want to wrap here. It's not about Crossplane versus Terraform. It's about using Crossplane to build your own control planes by wrapping cloud provider or whatever resource type that you have, sprinkling a little bit of policy on it, and then only exposing the resources that you want to provide to your particular developers as the platform team. And if that team wants to, if the users of your platform want to use something like Terraform or Puppet, they can. It isn't an all or nothing proposition. And with that, I'd like to end this presentation. Thank you.